All right, so today our goal is to talk about domain and range, one in which happens to be a topic that many people struggle with. I wouldn't necessarily say just in this course, but just throughout. I've just noticed domain and range being an issue. When we think about domain and range, more than likely what you think about is domains talking about the X, and the range is talking about the Y. If I could give you one thing to remember from this entire video, to help you, it would be when you're talking about domain, you're looking for the X's that are going to make this equation work. And mainly when they ask this question, they will ask with questions that have to do with square roots and with fractions. Domain is looking for what's going to keep this fraction or this radical or this equation working. And so what you're doing is you want to find out basically what's going to make it not work and then eliminate those, if you follow what I mean. So when we're talking about like a fraction, we're talking about what's going to make this thing undefined, because whatever makes that denominator equal to 0, that's where the problem starts to happen. And so we would have to eliminate that from the domain. If we're talking about radicals, or square roots as many might think about, what are we looking for there? What can't we have? We can't have negatives. You can't have a negative under the square root. And so therefore, you're looking for what's going to make that negative and avoid those numbers. Now, if we're talking about this example here with the absolute value of x, are there any x's that are going to make a problem? Or if we're talking about just g of x equals 4 or y equals 4, are there any x's that are going to become a problem? Well, no, there isn't. And so when there isn't any hiccup along the way we write it is you can either say all real numbers, or if you want to look real sophisticated, you would basically write it like this. It looks like a double bar R. And that's the notation for real numbers. So the domain for both is all real numbers. Okay? Sometimes you might see X and you might see something like what looks like an E, but it means element of the reals. That's another way of writing it. Sometimes you'll see with set notation X such that X is an element of the reals. All of those mean the same thing. All right, now, though, once you think about all the x's going into f of x, so once you think about all those x's, all the positives, all the negatives, all, zeros, the fractions, the whatever, once you think, what kinds of values do you get with an absolute value? Well, if you can picture the graph, we know that it bounces upward, and the y's cannot be negative. So therefore, my range for f of x, okay, is where y is greater than, can it be equal to 0? Sure it can. We can have it equal to 0. And so the range is not all the reals. Just because the domain is does not mean the range is. Because what kind of values do you get? If you think about this as like a machine, the domain is what you're putting into the machine that's going to make that thing work. And then what generates out of it is your range. What's the product that you're getting as you pump it out of that function? So similarly, let's look at g of x. If you think about g of x, I could put in all the positives, all the negatives, everything. And it doesn't matter what I put into it, what am I going to get out? Yep, I'm just going to get 4. So the range of this is y equals 4, and that's the only thing it can be. It's not that it can be less than, it's not going to be greater than, it's only going to generate 4. Let's do another one. F of x equals x squared. So let's just start with that and say, I'm just going to move this guy out of the way for a second. F of x equals x squared. So let's first start with f of x, its domain. And of course, are there any limitations to this? Nope. So I'm going to just put reals. The range of it, let's think about it. If I put positives in there and I square them, what do I get? And if you put 0 in it and you square it, what do you get? And if you put negatives in it and you square it, what do you get? So what then would be the range? y would have to be greater than or equal to 0, similar to the absolute value for the same basic reason. Obviously not with absolute value being the distance from 0, but x squared, when we square something, it makes it automatically positive. All right, let's do the next one, g of x. We just did this basically in the other one, so I'm not going to fuss too much about it, but same idea, g of x, our domain is reals, and our range is y equals 4. We'll leave it at that. Okay, so let's try this one. What if I have the square root of x minus 3? Yeah, I'm going to extend that over there. And g of x is x plus 4. So let's think of that. F of x, let's start with a domain. We have a square root, so that should send off some alarms into your mind. You want to think about what's going to make that thing negative. Well, it helps to start with what makes it 0. So something minus 3 equals 0. And of course, that would be 3, right? So we want to think about 3. So do I want to pick numbers that are bigger than 3 or less than 3? Well, I need to have numbers that are bigger than 3 in order for it to still work. So my domain is restricted to x's that are greater than. Can it be equal to? Can the square root of a 0? Can we do that? Yes, we can. And then when you plug those numbers in, what kind of range do you get? Can you think about your graph? And that's why this falls, by the way, after this. Think about your square root of x graph. That, of course, looks like this. Now, if I shift it to the right 3, I'll do that using gray here. What did it change the y values at all? Did not. Your y's are going to be greater than or equal to 0. Hopefully that makes sense to you. Now I'd like for you, for g of x, I'd like you to find the domain and the range for tomorrow's class. Domain and range.